Okay, we're still on multiple choice without the calculator, and we have 4 improper integral problems. So each time you'll see on each one of these, I've set up a limit, and then you have to figure out exactly why your expression is an improper integral. And in the first case, if I plug in u into my denominator, I have an undefined portion. This actually integrates to the natural log of u, which of course is undefined at 0. So I need to integrate from t to e, which is right here, and t goes on the bottom, but since I'm coming from e down to t, I have from above right here. So I'm going to evaluate my limit as t goes to 0 from above. I integrate 1 over u to the ln of the absolute value of u, which when I evaluate that from t to e, I get the ln of e minus the ln of t. And ln of t, as you come to 0 from above, that dives down to negative infinity. So this is actually going to be a divergent improper integral, and the answer is E, none of these. Second one is an improper integral, again because of our lower limit of integration. So I need to replace that 1 with a t here, and then again I'm coming in from above, so I put this little plus sign. I'm going to take the limit as t goes to 1 from above. So I rewrote my integrand. Instead of 1 over the cube root of t minus 1, I rewrote it as t minus 1 to the negative 1/3. That just makes it easier for me to evaluate or to integrate using the power rule, because I can quite clearly go up a degree to 2/3 and divide by 2/3, which is the same as multiplying by 3/2. Then I will evaluate from t to 2. So, and that's of course, well, let me do that first. So if I put in 2 here first, I end up with 1 to the 2/3, which is just 1, times 3/2. That gets me the 3/2 here. Then if I plug in, of course, t right here, I end up with minus 3/2 t minus 1 to the 2/3. And I need to take the limit as t goes to 1 from above. And when I do that right here, as we go to 1 from above, this zeroes out. So this whole term back here zeroes out, and my answer is just the 3/2, which is choice B. Now for 15, the reason why I've got an improper integral is because the integrand is undefined at 3. So I actually have to split this up into 2 limits. One where I'm taking the limit going to 3 from below. So I start at 2 and I go up to 3 from below. That gives me the from below. The other one is limit as t is going to 3 from above. I'm coming down from 4 to t, so I have the from above symbol. So when I integrate x minus 3 to the negative 2/3, I can add a degree to get to 1/3, and when I divide by 1/3, it's multiplying by 3. So I did the same integration for this guy and this guy, because I have the same integrand for both of them. So let's go ahead and evaluate the first one. I plug in a t. Let me write this out actually. I have the limit as t goes to 3 from below of 3 times t minus 3 to the 1/3 minus 3 times, then plug in a 2, I have negative 1 to the 1/3. I'm going to add that to the limit as t goes to 3 from above of plugging in 4 first. I just have 3 because 4 minus 3 is 1 to the 1/3 is 1 minus, and then plug in t, 3 times t minus 3 to the 1/3. So now if I evaluate my limits, let's plug in something close to 3 here, but just less than it. This effectively zeroes out. So some number 2.99999, this is going to have a limit of 0. Down in the second limit, if I plug in a 3.000001, this is going to have a limit of 0. So I end up with negative 3 times a negative 1 is 3. This one is just plain 3. So my full-on limit when I add those together is 6. Last improper integral on the page. Once again, I have to split it into 2 separate limits because my improper integral is in the middle of my limits of integration. My improper integral exists because this integrand is undefined where x equals 3. So I'm going to integrate from 2 to t and from t to 4. And do you see that I kind of took a little sidestep here, or skipped a step. I had 1 over x minus 3 all squared, and I integrated that to go up a degree to -1, divide by the new degree. This is my integrand, and I shortcutted that for the work I showed you, but that's how I got to this guy. And then what ends up happening is if I plug in t, so I have the limit as t goes to 3 from below of -1 over t minus 3 minus a -1, so plus 1 over 2 minus 3. Look what happens when I plug in 3 from below. So 2.99999999, I get effectively 0 in my denominator, which means the limit here is infinity. And I have one portion of my improper integral where the limit does not exist. Therefore, the entire improper integral has a limit that does not exist. This improper integral is divergent, and the answer is none of these.